Hi, I'm Joe James, and this is a two-part series on probabilities. In part two, we're going to do some more challenging word problems, typical of what you might see on the SAT or the ACT. Welcome back to the two-part series on probabilities. Let's dig into part two. Okay, problem number one. Lauren's world history teacher needs to select one of his 19 students to lead the class in song. Lauren's teacher decides that the song leader, who will be chosen at random, cannot be any of the four seniors in the class. What is the probability that Lauren, who is not a senior, will be chosen? Again, the formula for all probability equations is number of winning outcomes divided by the number of total outcomes. In this case, there's only one Lauren in the class, right? That's the only winning outcome is when Lauren is picked. So this is going to be one winning outcome because there's only one Lauren. There's only one case where Lauren gets picked. How many total outcomes are there? Well, there are 19 students, so maybe it's just 19. But wait. It cannot be any of the four seniors in the class. So if it's one of these four seniors that gets picked, we're just going to go back and draw another one until we get one of the non-seniors. So how many non-senior students are there? Well, 19 minus 4. So actually there are 15 eligible people to be picked. So in this case, the probability of Lauren being picked is 1 out of 15 because there are 15 non-seniors in the class. Number 2, what is the probability that Jerry will roll a doubles when he rolls a pair of six-sided dice? Let's see, we have a dice number 1 and dice number 2. And what does a doubles look like? So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So those are the winning outcomes, right? There are 6 possible winning outcomes. So here the probability of rolling a doubles is equal to the number of winning outcomes, which we just determined was 6, divided by the number of total outcomes. What are the number of total outcomes? So let's see, if you watch my first video in this series, the number of total outcomes, there's 6 sides on each die, and there are 2 dice. So we take 6 to the power 2, and this is 36. So there's 36 possible outcomes. So we're going to put our denominator is 36 because we're rolling a pair of 6-sided dice. And we can reduce this to 1 over 6. So there's a 1/6 chance that Jerry will roll doubles. Number 3, a bag contains 3 red marbles, 7 blue ones, and 5 green ones. 1 marble will be picked randomly from the bag. What are the chances of not picking a green one? Well, let's see, the probability of red or blue, right? Red or blue is equal to the number of winning outcomes, which is, let's see, 3 red marbles and 7 blue ones, so 3 plus 7. That's the number of winning outcomes. There's 10 possible winning outcomes. And the number of total outcomes goes on the bottom. So 3 plus 7 plus 5, because those are all the marbles in the bag. 3 plus 7 plus 5. And we add these up and we get 10 over 15. So the probability of not picking a green one is 10 over 15, and we can reduce that. Top and bottom are both divisible by 5. So we get 2 over 3, and that is equal to 66.7%. So that is the probability of not picking a green marble. Number 4, a drawer contains 4 blue socks and 10 red socks. What is the probability of Bruno randomly picking 2 blue socks in a row? Well, first, let's figure out what is the probability of him picking 1 blue sock, which is the number of winning outcomes divided by the number of total outcomes. Okay, well, there are 4 blue socks, so the 1 blue is going to be 4. And what is the total possible outcomes? Well, there are 4 and 10. There are 14 socks in the drawer. So this is going to be 4 over 14. We can reduce that to 2/7. Those are both even. Okay, so that's the probability of one blue sock. Now, on the second pick, Bruno has already taken one blue sock out of the drawer. So we have to base the second pick on what's left in the drawer. So the probability of, on his second pick, getting a blue sock is, let's see, how many blue socks are left? There were 4 to start with, but he already picked one. So there are now 3 blue socks left. Those are the winning outcomes, those 3 blue socks. There are only 3 left of the 4 that started. How many socks total are left in the drawer? Well, let's see, there were 14, but now there are only 13 because he took 1 sock out. So on the second pick, there are 3 blue ones left, and there are 13 total socks left. So the probability of a blue on the second pick is 3/13. Now, if you watched the last video, you saw that what we do when we determine the combination of both of these two events happening is we multiply. To get that, we multiply these two probabilities together. So probability of blue on the first pick and blue on the second pick is 2/7 times 3/13. So we just multiply those two probabilities of those two events together, each event. And here we just multiply the numerators and we get 6. We multiply the denominators and we get 91. So our probability here of 2 blues in a row is 6/91. Okay, problem number 5. A marble will be randomly selected from a bag of solid colored marbles. The probability of selecting a red marble is 5/19. The probability of selecting a blue marble is 4/19. What is the probability of selecting a red marble or a blue marble? Well, what if we assumed there were just 19 marbles in the bag? And 5 of them are red and 4 of them are blue. Probability of selecting a red marble or a blue marble would be just the sum of the two winning outcomes, right? Or 4 plus 5. And we would divide that by the number of total outcomes, which is 19. There are 19 total possible outcomes. So if there were 5 red ones and 4 blue ones, we would add those together. And then we divide by the number of total possible outcomes, which is 19. The 19 doesn't change. We don't add those together, right? Because there are still only a total of 19 marbles in the bag. So we get 9/19. Number 6. Zed has 12 green marbles and 12 yellow ones. What are his chances of picking 3 yellow ones in a row from his bag? And we're going to assume he doesn't put any marbles back into the bag. So he has 12 green marbles and 12 yellow ones. What is the probability of his first pick of picking a yellow marble? Well, it's 12. It's because there are 12 winning outcomes. And there are 24 total outcomes, right? 12 green and 12 yellow adds up to 24. And we can reduce that. That's 1/2, isn't it? They're both divisible by 12, so we get 1/2. So on the very first pick, his probability of getting a yellow is 1/2. We can see there are 12 of each, so it's 1/2. It's just like flipping a coin. Probability on the second pick of getting a yellow is a lot different here, because there are only how many yellow ones left in the bag? He's not putting them back. So he's already taken 1 yellow out of the bag. So there are only 11 yellow ones left in the bag. And how many total marbles are left in the bag? Well, 23. And gee, can we reduce that? No. So on his second pick, 11 out of 23. And on his third pick, his probability of getting a yellow one is, how many yellow ones are left now? Well, there's only 10 because he's taken 2 yellow ones out. And total marbles in the bag, there should be 22 left. We can actually reduce that. Both of these are even numbers. 5/11. So the probability of all three of these events happening, well, to get that we multiply these three fractions together. Probability of yellow, yellow, yellow is equal to 1/2 times 11 over 23 times 5 over 11. So we just have to multiply those three together. And let's see, this can be simplified some because these two 11s, well, we can cancel them out, right? We have an 11 on top and an 11 on bottom. So when we multiply the three tops together, we just get 1 times 5. And we multiply the bottoms, 2 times 23 is 46. So we get 5 over 46. And there's no way to reduce that, so that's our answer. 5 over 46 is this probability of picking 3 consecutive picks of all yellow. Number 7, we have a little graph here. So Mr. Harper's art class has students from 4 different grades. These are the grades, 9th, 10th, 11th, and 12th, as shown in the figure at left. If a student is randomly chosen from his class, what is the probability that student will be in 11th or 12th grade? The probability of 11 or 12 is equal to the number of winning outcomes divided by the number of total outcomes. What are the number of winning outcomes? Well, how many 11th graders are there? It looks like there are 6. So I'm going to call this 6. How many 12th graders are there? 9. How many 10th graders? It looks like there are 4. And 9th graders, I would say there are 8. Winning outcomes is 11th or 12th grade, so that's 6 plus 9. And the number of total outcomes is, well, all of these added together, right? Because these are all students in the class. So 8 plus 4 plus 6 plus 9. And let's see, we get 15 on the top. How do we get on the bottom? 27. And we can reduce that because they're both divisible by 3. So 15 divided by 3 is 5. 27 divided by 3 is 9. So the probability of picking a junior or senior is 5/9. Now our last problem, number 8. The graph below shows the number of students who were present on Thursday from each of the 5 groups in Ms. Reagan's class. What is the probability the students selected at random from the class on Thursday is in group 4? Well, first what I'd like to do is, let's see, looks like there are 8 people here. There are 12 here. There are 6 here. This looks like 2. And 5 group looks like 0. No people, I don't see any bar at all there. So probability that a student is from group 4. So how many winning outcomes are there? Well, there are only 2 people in group 4. So that probability is equal to winning outcomes divided by total outcomes. There are 2 winning outcomes. Total outcomes is basically the sum of all of these. So let's see, how many are there? There's 8 plus 12 plus 6 plus 2. So let's see, that looks like 28 to me. Just adding all these together to get the total possible number of outcomes. And we can reduce this because they're both even, so we're going to get 1 over 14. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.